Hello, welcome to the FRQ of the day. So today we are going to do the 2010 number 2. So let's see if you can figure this one out. So this one says a local radio station plays 40 rock and roll songs during each 4-hour show. The program director at the station needs to know the total amount of airtime for the 40 songs so that time can be programmed during the show for news and advertisements. The distribution of the lengths of rock and roll songs in minutes is roughly symmetric with a mean of 3.9 and a standard deviation of 1.1. Part A, describe the sampling distribution of the sample mean for song lengths for random samples of 40 rock and roll songs. And Part B, if the program manager schedules 80 minutes of news and advertisements for the 4-hour or 240-minute show, only 160 minutes are available for music. Approximately, what is the probability that the total amount of time needed to play 40 randomly selected rock and roll songs exceeds the available airtime? So if you want to pause the video and give that a shot, that would be great. Okay, so you've got this situation where asks us to describe the sampling distribution. Now the population here has a mean of 3.9 and a standard deviation of 1.1. It doesn't tell us that it varies approximately normally. It just says it's roughly symmetric. For all we know, it could be bimodal, or we don't really know the shape. We do know it's symmetric though. But we don't know that it's normal, okay? But the thing about it is, the central limit theorem tells us that when you take a sample of size 40 and find the mean, find the average of those 40 songs, okay, the sample, every value that mean can take is approximately normal. What that means is we take 40 songs and find a mean. Okay, now the average of these 40, the average of all the songs is 3.9. So when you take 40 of them and average them, we're expecting it to average 3.9, but it's going to be a little bit off because of sampling variability, okay? And the sampling distribution is the concept of, what if we took many samples of size 40? We took another sample of size 40 and found the average of those. And it took another sample of size 40 and found the average of those, and so forth. And we found all these sample means, is every one that we possibly could, okay? This family of X bars, that's what we call a sampling distribution. They will be centered around the population 3.9 as long as we aren't doing anything in a biased way, which we're not. We're randomly selecting them. And then how are they going to vary? There's going to be less variability. Whenever you average data like this, there's less variability going on. And so the standard deviation of these X bars is equal to our sigma over the square root of n. And so now, by the way, and on your formula sheet, if you go to the second page of your formula sheet and you go down here for means, all right, the sampling distribution, all right, the mean of the X bars is equal to mu, and the standard deviation of the X bars is equal to sigma over the square root of n. So all that to say is that this particular sampling distribution, describing it, of course, describing a distribution, you have to cuss, you have to describe its center, its unusual values, its shape, and its spread. And so the sampling distribution of the sample mean song lengths will be approximately normal, so that takes care of the shape, with a mean of 3.9, that takes care of the center, and a standard deviation of 1.1 over the square root of 40, and that takes care of the spread. Now, by the way, the unusual values or outliers are taken care of by saying it's approximately normal. That describes the nature of the outliers as well. So that is how you would describe the sampling distribution. And then the next question is that, okay, what is the probability that the total amount of time to play the 40 songs, rock and roll songs, exceeds the available time? Now, up here, we were dealing with the mean of the song. So one way of looking at this, you can say, well, if the 40 songs take 160 minutes, all right, so that means the average in this case is going to be 160 over 40, and so they're going to average 4 minutes. That is our mean, okay? And using the sampling distribution above, we could do normal CDF, okay? And so the mean of the 40 songs would be equal to 4 minutes. And so what's the probability that 4 minutes on average is going to happen, given that our sampling distribution is centered at 3.9, and given that is our given that's our standard deviation? Well, and so that's going to be probably 4 or more. You know, and if ever you're asked to find a normal calculation, I encourage you to draw the curve, all right, and show the proper shading, and then there is the normal CDF calculation. The probability of getting from 4 to infinity, given the mean is that and the standard deviation is that. Notice I've labeled it properly. And of course, normal CDF on your calculator, which we've done many times. So let's do that. And so we would say second distribution and go down to normal CDF, and then the lower value's 4, the upper value is infinity, or you could just put 9 trillion or something, and then the mean is 3.9, and then the standard deviation is 1.1 over the square root of 40, and so then we hit paste. In some calculators, it'll immediately appear like this. It'll just give you this command like that, and so you have to enter those 4 numbers with commas in between them. But anyway, so you hit enter, and so it's that, and so that's the answer to that. It's about 28.27% or so the probability that they're going to run over time in this case. Okay, that's it. That's your FRQ of the day. Thank you for stopping by, and I hope you're doing well. Really miss seeing you guys, and if you have any questions, please send them to me. I look forward to seeing y'all again soon.